Welcome back to the FAST lecture series. Today we're going to review the emission spectrum. We've talked about this before when we talked about visible light, or the EM spectrum. We're going to revisit this topic, but more in the context of how we can determine what an element is solely based on the light that it produces. In order to understand that, we need to look a little bit more closely at the atom itself. Atoms are made up of protons, neutrons, and electrons. We're going to focus mostly on the electrons that are whizzing around the nucleus. They are attracted by the proton's positive charge. And while it's easy to think of electrons behaving in this way, just kind of spinning around, it's actually way more complex than that. The long and short of it is that the electrons are only able to occupy a very specific volume around the nucleus of the atom. In other words, it can live in a space somewhere in here. We don't know exactly where it's going to be, but that space is going to depend on the electron's energy. Think of these volumes as stairs on a staircase, where the landing down here is the nucleus. Lower volumes are lower steps, and higher volumes are higher steps. Now we're going to just arbitrarily call an energy unit EU, just as kind of a short way of saying this. When you go up a step, so if we take this electron and go up a step, you lose energy. It's going to take energy to do that. This is going to be the same amount of energy that you will need to also go down one step. So you have to go up a whole step at a time. So you need a very specific amount of energy to do it. So we'll just say that this is one energy unit. And it's going to be the same going down. It's going to release one energy unit when it goes down. Likewise, that electron can also travel up 2 steps at a time. And that's going to take 2 energy units. And it'll be the same going back down. So those energy units, it's going to be the same amount of energy going up as it is going down. So where do electrons get this energy from in the first place? They're going to be getting these from light. So if light is hitting an atom at just the right amount of energy, its electrons are going to move up an energy level. It could also move up 2. It could move up 3 if it has the right amount of energy. The energy light has is dependent on its wavelength, which we've talked about when we discussed the EM spectrum. Specific wavelengths of light are required to move certain atoms' electrons up and down energy levels. For example, hydrogen is going to require different wavelengths of light to move up and down energy levels than, say, helium or calcium. This means that depending on the light an element is giving off, we can determine what that element is, and we call this the emission spectrum. Think of this like a fingerprint. This is going to be the fingerprint of an element. Every element is going to have a unique emission spectrum. We can use this to determine what substances on Earth are made of, or even what distant stars or planets are made of. For example, if we look at helium, helium's emission spectrum looks like this. It's going to show a little bit of red light, and then there's going to be a lot of space. You'll see a little bit of yellow light in there, and then it skips down some more, and you'll see a couple of wavelengths of blue that kind of start to get a little bit darker as you go. And then at the very end, you're going to see some very deep purple. You'll see 2 purple wavelengths at the very end. And this is helium. Helium will always look this way. You're going to see this spectrum for every helium element that you ever see, which is why when we look at stars through a spectrometer, we can see these wavelengths, and therefore we know that helium is a part of that star or a part of that planet, and it's not something else like hydrogen or calcium. Cool stuff. And that's the end.